Hello, this is Elizabeth, and Engineering Economics video 6 is what we're talking about today. Looking at uneven payments, payments that are uneven payments, payments that are different in amount over time. And then we'll look at even payments that are the same in amount and a series of them over time, right? Earlier, we had just been looking at single sum, one cash flow coming in or out at one point in time. Now we're going to look at lots of payments that happen over time, both different amounts and a shortcut when it's the same amounts each time. So a series of future dollar amounts that are different from each other. Let's look at that first. Here we have a cash flow diagram with $100 coming in at time 0, $50 coming in at time 1, and $125 coming in at time 2. The question is find P, find present value when the interest rate is 4%. Okay, so the approach that we take to problems of this type is that we need to calculate the present value of each individual cash flow separately and then add them together. So basically, this $100 coming in at time 0 already is in terms of P, right? So we don't need to do any adjustment with that. It already is in terms of P, and that's what we're trying to find. This $50 that's happening out 1 year back, or 1 year into the future, we have to take that and discount it back to its equivalent present value 1 year back in time using an interest rate of 4%. And similar here with $125, it's happening at year 2. We want to discount that back to its equivalent present value 2 years back in time. So we'll use the discount factors on the 4% interest table, the 1 year row and the 2 year row. So here's our calculation. Present value equals $100, that's already in terms of P, plus $50 times a factor from the interest table, 4% interest table, year 1, so 1 row down, in the find P given F column. Find P given F column. Find that factor. Here it is here, 0.9615. Multiply that by the sum, the cash flow payment just in front of it. Then our last payment is $125. Again, we multiply that by a factor found on the 4% interest table, row 2, same column, find P given F. And that factor is 0.9246. Multiply that by the cash flow, $125. Remember, this $100 is already in terms of P. Then we just add those three sums together, and we get the present value is equal to $263.66. Now, in words, what does that mean? Interpret that in words. Something like the cash flow diagram shows payments over 2 years that are equivalent or equal to $264 today at interest rate of 4%. So we would be indifferent into receiving $264 today or this series of cash flows over the next 2 years, because according to time value of money concepts, they are the same. All right, now let's look at a series of future cash flows that are the same. They're the same every year. Like right here, we have 3 cash flows, each $100. When that happens, we call it an annuity. When you have a series of payments either coming in or going out, it doesn't matter. We call it an annuity, and it's designated by the letter A. So the question is, we can find the present value when interest rate is 4%, or we can find the future value when interest rate is 4%, or any percent of interest growth rates. So why not just add the 3 together? Is the present value $300? Is the future value $300? Why or why not? The answer is neither one is exactly $300. When we have high interest rates, or a long period of time, the present value is going to be significantly less than $300. Again, when we have high interest rates or long periods of time, the future value will be significantly more than $300. When times are short, the time period is short and the interest rate is low, these values will be fairly close to $300. Let's take a look. First, the important concept here, just to summarize, a series of cash flows that are the same in dollar amount and happen regularly are called a uniform series. That pattern is called an annuity and designated by the letter A. Examples of this are rental or lease payments, commercial installment plans, bond interest payments, car payments. You can probably think of some more examples. So let's go ahead and find the present value and future value of this annuity. We'll solve this one. Find the present value of that annuity when interest rate is 4%. So just to put a little bit of context to it, what amount would you have to invest now, today, right, present, in order to withdraw $100 an annuity at the end of each of the next 3 periods? What amount would you have to put in the account now in order to withdraw $100 at the end of the next 3 years? So here's the approach that we'll use. Let's find our knowns and then figure out what we have to figure out. So knowns are, we know the annuity is $100, we know the interest rate is 4%, and we know the time period is 3. That payment happens 3 times. The unknown, what we're looking for is find P. So if you like the equations, here is the equation to use to find P for an equal payment series present worth factor. If you like the equation, there it is. Again, the interest table has calculated that for various interest rates and time rates, and this will be a factor on the interest table. So this and this are the same. In either case, you multiply what's in the brackets there by the dollar amount of the annuity to find the present value of that annuity. So here's the example again, same series of cash flows, find the present value, same example. I just copied it here again for you. And there is a shortcut formula using the interest table, which I've duplicated here. So again, we're on the 4% interest table, looking at equal payment series, finding the present worth. So we go to this column, find P given A, and we go down to year 3, and there's a factor, 2.7751. which we multiply by the annuity amount 100 and get a present value of that series of cash flows, $277.51. So a little less than $300. Similarly, we can find the future value of that same annuity cash flow stream. Here's how we write future value, annuity amount times a factor from the table, $100 times, where did I get that factor? 3.12. Well, let's take a look here. For the future value, I go up to, again, equal payment series, same 4% interest table, equal payment series, but now we're trying to find F given A. So look at here, compound amount factor, find F given A. So again, we go down to line 3 because it's 3 years, and 3.1216. That's where I got that amount right there. Multiply it by the payment amount of 100 in the annuity, and it's a little more than $300, $312.16, a little bit more. And then the 300 payments just added together. So that's how you find present value and future value of an annuity. Now notice here, one more thing on this page I want to point out. Our annuity starts at year 1. And that is because we assume that all payments happen at the end of a year. That's called a regular annuity. If you find a case where the payments happen at the beginning of the year, that's called an annuity due, and we have to shift everything back 1 year. We'll do that in video 7. But for right now, we're assuming these annuity payments happen at the end of each time period, a regular annuity. So just to show you again, if you prefer the equation or want to make a cheat sheet, a note sheet of the equations for these things, here's the equation for find F, equal payment series, right, meaning an annuity. compound amount. That's what we just found. Find F given A. There's the big formula. And that has been summarized in the interest tables for you in the Find F given A column. Equal payment series, compound amount. That's what we just did. All right, so to end this video, here's a practice problem for you. Suppose that you make an annual contribution of $5,000 to your brand new Roth IRA account at the end of each year for 5 years. If your account grows at 6% annually, how much would be in the account at the end of 5 years? So here are 4 steps. The approach here I'd like you to take is 4 steps. Draw a cash flow diagram, identify the knowns and unknowns, select the appropriate equation or table value, and solve. I'll give you the answer at the beginning of video 7. Thanks. The end.